step out for like 2 minutes. I mentioned that. So when I do, probably wouldn't be a bad idea to read a little bit in the chapter, or go to the bathroom or something. When I go, I won't be gone long, but just thought I'd mention that. I'm not going to pause recording or anything because I think that'll be a bigger pain than it needs to be. Here's our title screen. Give you a couple seconds to write it down and then decide whether or not we should make some decisions now about the test or wait. Ugh, that sounds gross. Computer's scraping something on my desk. So if we do this kind of just super straight, kind of the way we've done most of our other units, 5 lessons, that would be today, Thursday, and then Monday, Tuesday, Wednesday of next week. We would be kind of done the teaching part. Thursday would be a study day. Friday, you guys don't have school. Monday would be the test. As I say this out loud, I'm thinking maybe let's just treat it that way tentatively, and then as we go, if we need to add more time and things like that, then so be it. Thoughts? Anybody?
Yeah, it's good.
So tentatively, if today's 18, so 17, 16, 23, 30. So November 30th, tentatively, will be our our test day. Tentatively, November 30th. I should jot that down somewhere so I don't forget. November 30th pre-cal test. Okay. Tentative. Everybody's copied this down? Yes. If I'm going through the slides too fast, say so, please. You don't have to copy these down. I just wanted to show you this is the world we're entering. Please try not to let it freak you out. These are identities. They're all going to be given to you. You don't have to memorize any of them. Basically, what's going to happen in this unit is you're going to be given proofs. The vast majority of this unit is prove that the left side equals the right side. And to do that, we will use at different times these different identities to make substitutions to make one side equal the other. This probably all just sounds weird, but it'll make sense as we go. For today's lesson, can you see the cursor when I'm wiggling it around the screen?
Yes.
Okay, this is these are the identities we're going to be talking about today that we're going to use today. It's what we're starting with. And again, you don't have to copy them down. Doesn't hurt, but it's in your textbook. This stuff will be given to you. I put down which you will do in calculus. There's at least probably a few of you are laughing as if I'm taking calculus, but you never know. So with these identities here, the reciprocal identity, the quotient identity, also, by the way, I'll never ask you, what's this identity called, or things like that, because you're going to be given 1, 2, 3, 4, 6, like 12 different identities. You don't have to name them. Don't worry about that. But it's just kind of saying that these are true. We know these are true. Tan of theta equals sine over cos of theta. And so these are just simple little examples of places we may need to substitute. These ones will not be given to you. These ones, the hope is that you memorize them. Tan is sine over cos. Same with like cosecant, secant, and cotan. I think you guys know those ones anywho without putting a whole lot of thought into it. Anyone need more time on this page?
Yeah. Yeah.
Okay. We'll have to figure out who among us is the slowest writer. Hey, give me 2 seconds. I'll be with you. Please tell me when you're done writing.
I'm done. I'm done. I'm good.
Okay, I'm going to put it on the next slide. I'm going to fill the slide, and then I'm going to walk away for a couple minutes. I'll be back. Do you have these? Wait. Is it on the sheet? No. Okay. Didn't take me as long as I thought it would. Okay, so these identities here are called the Pythagorean identities. You can probably imagine why. Y squared plus x squared equals r squared. So this is the radius for a unit circle. Sine squared plus cos squared equals 1. Now, just to be clear, it's written like this, sine with the 2 and then theta, but really it's sine of theta, if you kind of put that in brackets, squared. So sine squared of theta is sine of theta times sine of theta, just so you know, for when we're kind of breaking it up and doing some other things. These two, and again, you don't have to memorize them. It just might be that you see cosecant squared of theta somewhere and you're like, man, I don't know what to do with this. You can substitute this in, and so on and so on. You might see sine squared plus cos squared. You want to change it to 1. You might see a 1. You can change that to sine squared plus cos squared, etc., etc., etc. And there are variations. Like you could have cos squared theta equals 1 minus sine squared of theta, and so on. We will use these to make substitutions. These proofs are left-hand side equals right-hand side. So it won't be like solving where you kind of divide both sides by 5 and then subtract this from both sides, blah, blah, blah. We're keeping them separate. We're trying to make one side equal the other. At some point on page 200, there's some skills, just kind of some little friendly reminders, like to turn these ones upside down and things like that. The biggest one, the reason I put these asterisks was to remind myself, is multiplying by a conjugate. So that one, you can make a note of that, multiplying by a conjugate, to give us a different look, and we're going to do that in the examples anyway. I already said this when doing the proofs. We must keep the left-hand side separate from the right-hand side. Does everybody have this down?
Yeah. Yes. Yeah.
Cool. All right. So you will always kind of be referring to these. That's why I put it down again. It's not like you have to copy these down every time they're there, but we will use them lots. I have a formula sheet that that I'll give everybody. I may have posted it on Classroom. Did I post it on Classroom, the formula sheet? People aren't sure. Okay, it's fine. Oh,
I don't think so.
You don't think so? I'll give everybody a hard copy, and I'll try and remember to post it anyways, just so you guys know what you'll be given. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, there's 11 identities, not 12.
I'm good for this slide.
Thank you.
Me too.
Thank you.
Yep, good.
Cool beans. All right, so that's it for the notes. Let's look at some examples. Okay, so can you guys? We're writing theta. So when I see if they're all the same, like in this question, you know, it's all A. I just write theta. You can write A. You can write whatever you want. I just prefer writing theta. So tan of theta over cos of theta. It's also funner to say. Who wants to say A when you can say theta? 1 plus sine of theta. Okay, so this is my left side, this is my right side. The right side looks pretty simple. There's not a whole lot that's kind of changeable there. Like everything's changeable to a degree. But this is the one that looks complicated, so I'm going to try and make this into one term, see if I can make it to this. So I may not even touch this side. That's what I'm thinking. So secant is cosine, so it's 1 over cos squared of theta, minus tan of theta is sine of theta over cos of theta, all over cos of theta. Now cos of theta, like anything on its own, is the same as if it's over 1, and I write it this way so we can flip and multiply. So when we flip and multiply to reconcile this, excuse me, we have 1 over cos squared theta minus, when I flip this one, cos goes to the bottom, so it's going to be sine of theta over cos squared theta. So 1 minus sine of theta over cos squared theta equals still this same side. So this, we need to make it equal this. Clearly, we have a little ways to go. This is the part where I was talking about multiplying by the conjugate. That's the biggest hint that you may not kind of think of or see on your own. To multiply by a conjugate, I'm trying to remember how I kind of taught this before. It's kind of like if I have like x minus 1 over x, whatever, who cares. If I want to multiply by the conjugate, I multiply this by x plus 1 over x plus 1. So I'm multiplying it by 1, but it's going to change the top. It's kind of the other half of a difference of squares. So that's what I'm going to do to the top here. So I'm going to do 1 minus sine of theta times 1 plus sine of theta all over cos squared theta times 1 plus sine of theta. I'm writing with a marker, so it's taking up lots of space.
So
go ahead.
What exactly is a conjugate?
It's like it's the other half to a difference of squares. So like when I was doing this, on the top here, like the conjugate of x minus 1 is x plus 1. So this becomes x squared minus 1. It becomes a difference of squares. So it's the same idea. So the conjugate of this is 1 plus sine of theta. If we were doing this side, the
Okay.
conjugate of this is 1 minus sine of theta. So if I wanted to introduce that, I can't change the total value, but something over itself is 1. So I could multiply this by 1 minus sine of theta over 1 minus sine of theta. Okay? Like this right here, this equals
Okay.
1. So I'm multiplying this side by 1. It's going to change what it looks like, but that's okay. So because I kind of see where this is going, notice this is 1 over 1 plus sine of theta. I have 1 plus sine of theta in the bottom here. So I'm not going to multiply this through because I want to kind of keep this. So I'm going to do some stuff here and see what happens with this. I know this is like Greek, like instantly, it's weird. Trust me. Stay for the ride. So I know this is a difference of squares. I don't have to do all the steps. 1 times 1 is 1. Negative sine squared of theta all over cos squared of theta times 1 plus sine of theta. Now 1 minus sine squared of theta, let me find, so the identity that we're given today, these Pythagorean identities, these are what we're given today. Sine squared of theta plus cos squared of theta equals 1. So if you look at this, if I subtract sine squared of theta from both sides, cos squared of theta equals 1 minus sine squared of theta. So on the top here, I can substitute cos squared of theta. It's going to cancel with here, and I got my identity. Did I lose anybody there? No? Okay. So it becomes cos squared of theta on top. Sorry for this squiggle, this pen check from something. So we're left with 1 on top, and on the bottom is 1 plus sine of theta. Works. I'm stopping there just because I ran out of room. I would ask that you do the one more step. And it's always good to say something at the end, like right-hand side equals left-hand side. I guess I got those backwards, but whatever. Something like this, or it's proven, just something that tells me it's done. QED, something that tells me you've reached the end, you're happy. Questions about this? I'm going to have a sip of water. Okay. Next question. Where are the questions? Number 3. Oh, there's 4. I think I said do 1 to 3, but we'll do all 4 if you guys want. You can bow out if you want. If you think, this is easy, I can do this. But each one's a little bit different, and the stuff is generally brand new. Number 3. Prove that cos of theta over 1 minus sine of theta. So now, when you see something like this, have in the back of your head, this might be a conjugate. I might have to multiply 1 plus over 1 plus. So just keep that in your brain. Anyways, prove that that equals secant theta plus tan of theta. So it looks to me, the first thing I'm going to do, this is the more complicated side, so I'm going to simplify this. This is in one term. I'm going to simplify this, try and get it in one term, and see what it looks like. Secant is 1 over cos. Tan is sine of theta over cos of theta. So they already have a common denominator. It's kind of nice and easy to deal with. 1 plus sine of theta over cos of theta. And it does look like a conjugate. We either do this side or this side with the conjugate. Doesn't matter which one. I'm going to do this side. The only reason I'm doing this side is because I got more room. I might run out of room. If I do it here, I might run out of room when I go down. It really doesn't matter which side you do. So on this side, we have cos of theta times 1 plus sine of theta over 1 minus sine of theta times 1 plus sine of theta. My equal signs are not lining up. I'm not online to paper. You guys will be. So anyways, I'm going to keep these separate for the time being just to see what happens down here. So cos of theta is cos squared of theta. That's just kind of a version of one of the Pythagorean identities. So I'm going to change this bottom part to cos squared of theta. So we have top is cos of theta times 1 plus sine of theta. Notice how we're starting to look like the other one already. All over cos squared of theta. Well, cos squared of theta is cos theta times cos theta. So it can cancel with one of these bad boys. Cha-ching, cha-ching. And now I've got what I want. 1 plus sine of theta over cos of theta equals 1 plus sine of theta over cos of theta. QED, left-hand side equals right-hand side, blah, blah, blah. Now, remember I did the conjugate on the left. I could have just left it as this and then did the conjugate with this. Doesn't matter. It'll work out. As long as you're following the laws and rules of math, it'll work out. Any questions? Am I going too fast? All right, sounds okay. From where I'm at, I can't see if anybody's even still there. I assume you are. Number 4. If you're not, you've got to record this anyway. Where's top of page 4? Says, prove sine to the 4 of theta. It says A. Minus cos to the 4 of theta equals 2 sine squared theta minus 1. Well, this is interesting, hey? So the first thing that my brain sees, I'm trying to see, like, can I change this to something that 2 messes with me? I don't know what to do with that. This one I know is a difference of squares. These are each a square. It's not normally the way you would see it. These are each a square, and it's separated by a negative. So I can rewrite the left side, which is clearly where I'm going to start. Sine squared of theta plus cos squared of theta times sine squared of theta minus cos squared of theta. And then this has to be moved over. So now with these, sine squared of theta plus cos squared of theta, do you remember what that equals? That equals 1. That's one of our identities. Exactly. Sine squared of theta plus cos squared of theta equals 1. So I can, in 1 times, it doesn't change it, so I can rewrite this as sine squared of theta minus cos squared of theta equals this. So far, this doesn't look like anything. This is also a difference of squares. Okay, 2 squares separated by a negative. Sine of theta minus cos theta times sine of theta plus cos of theta. Now I'm in this moment right now, I'm a little bit stuck. I'm like, what do I do with this? And I'm not sure because these don't cancel, they don't do anything. So what I'm going to check is this sine squared of theta. I know sine squared of theta equals 1 minus cos squared of theta. So I'm going to put that in and see what happens. I feel like I might have gone down the wrong path here, but let's just see because this happens. So sine squared of theta is, what did I say, 1 minus? Yeah, 1 minus cos squared of theta minus 1. So this equals 2 minus 2 cos squared of theta minus 1. 2 minus 1 is 1, so this equals 1 minus 2 cos squared of theta. Well, what in the world do I do with this? Okay, well, you know what I could do? Let's kind of ignore this line. I'm going to go back to this for 1 second. Sine squared of theta minus cos squared of theta. We have cos squared here. We're going to keep this cos squared and we're going to substitute like we did on the other side. This says sine squared of theta. That's going to be 1 minus cos squared of theta minus cos squared of theta. So it's going to be 1 minus, there it is. So negative cos squared of theta minus cos squared of theta is 1 minus 2 cos squared of theta. So that one went a little bit weird. I did a little bit more work than I needed to, but that is normal. That will happen. You have to kind of play and substitute and wiggle and jiggle and see what fits. All right, so your assignment. I just want to talk about the assignment really quick because it might look a little bit weird. So for the assignment, it says for the following statements, so like, for example, here's the first one. When theta equals 45 degrees, it says verify for the value given. So what it's asking you to do with your calculator, hang on one sec. I think somebody need to talk to me?
No.
Okay, you're just wandering down the hall, doing laundry?
Yeah, the cover key.
Yeah.
Are you recording?
Yeah. So verify for the value given. So what it wants you to do is it wants you to put in 45 degrees everywhere there's a theta. Just punch it into your calculator and check that it makes sense. If it doesn't, if the left side doesn't equal the right hand side, then you're doing something wrong with your calculator. So get in those kind of good habits. Then it says verify using a graphing calculator. You don't have to do like 1 and 2 for every single one. Graphing calculator, put it in Desmos. Put this in Desmos and then put this in a different line. You can ignore that part. So you're just putting this in one line, this in another, see if those equal, and then prove algebraically, which is what we've been doing. So that's what that is. Part 2 is just proving. Question number 3, it says identify the values of the variables in question 2 above for which the identity is undefined. So basically what it means is every time there's any kind of fraction, this is a fraction, this is a fraction, this is a fraction, these are the cotans or fractions. Always look at the denominator. What would make the denominator 0? Those are the values for theta. It wants in radians between 0 and 2 pi. So for this first one, for example, I'll do that one quickly. So I'm going to use a pen just because markers are so big. If you can't see this, please say so. But basically, we want to see what on the left-hand side, what makes it 0. So 1 minus sine squared of theta equals 0. So if I just move sine squared of theta to the other side, 1 equals sine squared of theta. So what value of theta squared equals 1? So if you think of our unit circle, sine is y. It equals 1 up here. So this is 0 and 1. And equals negative 1 down here. Negative 1 squared equals 1. So the value of theta is pi over 2 and 3 pi over 2. Those are the values of theta that make this undefined. That's just the left-hand side. For tan of theta to equal 0, sorry, not equal 0, that's wrong. Tan of theta, oh, you can't see that. Tan of theta equals sine of theta over cos of theta. So wherever cos of theta is 0, it won't work. And it happens to be the same for the left-hand side. Cool, cool, cool. That's all you got to do for number 3. Any questions? If there's no questions, that's the lesson, my friends. All G?
Yeah.
Cool. People are leaving. All right, see you guys. Zoom and then screen record for people who don't want to be part of the live lesson.
Who was that last? Yep.